So in this video, I'm going to go over 8.2 practice number 3. So for bell work, what I wanted you to do was sketch the part of the graph in blue that is increasing, and then in orange, do the part that's decreasing. So the first thing you should do is draw a vertical line that cuts the graph down the middle. That's the axis of symmetry. And then start to color. So if you were traveling, if you were walking on this graph, then the sides to the right would be increasing. Because look at my pen movement, it's going up towards the sky. So that's how I know my y values are increasing. And they're increasing all the way from the wall, all the way to the right, because we read the graphs from left to right. Now, if I started my journey on top of this graph, I would be moving my orange scribbles all the way down until I hit the wall, because the wall, the axis of symmetry, is where the graph, it's like the bouncing point. It's where it stops and then it changes direction. Now, the new part is coming up with the interval of increasing or decreasing. So we want to take a more closer look at the axis of symmetry. The axis of symmetry is x equals 5. That's the wall. That's where your movement changes. So since it changes directions at x equals 5 and we want it to change where it increases, we're going to start where x is 5, and we are traveling to the right. And remember, the graph goes on forever and ever, so traveling to the right is towards positive infinity. So the level of increasing, or the interval of increasing, is a positive 5 to a positive infinity. Now remember, we're reading the graph from left to right. So we're starting to the left for the orange, for the interval of decreasing, and all the way to the left is negative infinity, but it stops. Where does it stop? It stops at x equals 5. So we're going to do negative infinity to positive infinity. Now when you switch over to slide number 2, you're going to notice that the graph is upside down. That doesn't change what you do. You still draw your wall in the middle, okay? Axis of symmetry. That wall is where x is negative 4, because it cuts through the negative 4. Now start to shade. It says blue is increasing. So I know that my graph is going up the hill on the left side and going down the hill on the right side. So then it says level of increasing. So you're traveling from left to right and then you hit the wall. So you started your travels on negative infinity, and you hit the wall where x is negative 4. Now, for the level of decreasing, we're going to start at the wall, which is negative 4, and we're going to go to positive infinity. Now to write the symbol infinity, you just need to type the word out. Now for slide number 3, it's really important to remember when A is bigger than 1, it's going to be narrower. If A is between 0 and 1, it's going to be wider. And then negative A just flips it upside down. So you want to kind of categorize, like let's do all the upside down graphs here, and let's do all the right side up graphs here. So my A for 9x squared is 9, so that's a bigger number than 1. So my graph is more narrower, however you want to say it. Now 0.7 is like 70 cents. That's between 0 and 1. So that's a wider graph, and it's positive, so it's pointing upwards. Now the negative sign makes it flip, so I know I'm going to be upside down. And then the 0.25, that makes it wider. So that's correct. And then if you do negative 20 divided by 3, that's going to get you a negative, which flips it upside down, reflects it. And then the 20 divided by 3 gets you 6.6 repeated, which is definitely bigger than 1, so that's why the graph is narrower. All right, for this one, I know that a lot of you want to write the equation as something fancy, but when the axis of symmetry is shown, it's cutting the graph down the middle, and a vertical line will always be x equals. So where is that x? It's 1, 2, 3 over. So x equals 3. Now on slide number 5, I'm going to ask you the same thing, but I'm actually going to ask you of the vertex too. So the vertex is the bouncing point. So it's negative 5, 2. But if you were to draw that vertical line that you just did in slide 4, what would the x value be? The x would be the x of your vertex, which is negative 5. All right, number 6. So number 6, or slide number 6, we always start out with the vertex form. Now I recommend writing your h, your k, your a. So we said a is 1, we said our h is negative 3, and we said our k was 2. The reason why we know that is the vertex is always h, k. So now we're just going to plug it in. We have the a for 1, we have the x minus from the equation, and then the negative 3 from the problem. And then we have a positive 2 from the problem. Now the only thing that you need to simplify is that minus a negative, or negative times a negative gets you that positive 3x, or I'm sorry, x plus 3. So that's the only difference between what you have to do. And remember, when you're dealing with the equation, it's always the opposite of what you see for the h value. Three. All right. And then in the next slide, you're going to do the exact same thing. So we said our a value was 1. X minus comes from the equation 5 squared plus 6. So minus a positive stays a minus. So this is your equation. Notice the h is the opposite of what you see when you're dealing with the equation. And then the k just gets thrown out on the end. Okay? Okay, so slide 8 is all about working backwards. So this is where your h should be, this is your k. So since we're dealing with the equation, it's the opposite of what's inside the equation. So I see a negative 3, so my h is going to be 3. And then my k is just hanging out on the end, which is going to be a 7. So 3, 7. Your x value, your axis of symmetry will always be your x value of the vertex, so it's x equals 3. And then there's really a number right here. There's a 1, even though we don't write it. And since it's positive, it's going to be concave up. And of course, you're going to write in complete sentences. I'm just more talking than actually writing. All right, slide number 9, use the graph to help you, to be honest with you. These points are visible once you click on them. All you need to know is the vertex is the bouncing point. So it's going to be negative 3, 8. Now in the last 3 slides, or at least 3 or 4 slides of this activity, we've talked about the axis of symmetry. The axis of symmetry is the x value of the vertex. So in my vertex, it's going to be negative 3. Y-intercept is exactly what we think it is. It's where it crosses the y-axis. And then zeros, that's just a fancy way of saying x-intercepts. So negative 7, 0, and 1, 0. All right, now it brings us to the problem like bell work, okay? So bell work, we said blue was increasing, and you don't have to color code it if you don't need to. And we said orange was decreasing. And notice I switched colors at the vertex. Remember that wall, that vertical line. The vertical line is right there in your table already. It says x equals negative 3. So when is our graph increasing? Remember, you start from left to right. Left all the way over here is negative infinity. And what does it hit? It hits x equal negative 3. So if you type that in, and you actually write negative infinity and a 3, or negative 3 rather, you'll get it right. Now, which interval is it decreasing? Remember, you start at the wall. You're starting at x equals negative 3, and you're going all the way to the right, which is called positive infinity. All right, and now we just do the same thing. This graph is just concave up. So we actually have a minimum. So that's going to be 2.5 comma negative 6. Axis of symmetry is just the x value of the vertex. You have to make an equation, x equals 2.5. Crosses at 0 comma 19. And then the 2x intercepts, and it's okay that these are decimals, okay? Not everything is a perfect integer in math. So decimals are allowed. Most students get fearful when there's decimals, like you did something wrong, but you're good here. All right. So let's color the graph where it's increasing. My pen's moving up, so I know I did it right. My pen here is moving down. When I trace it, notice I'm stopping at the bouncing point. What do we call that? We call that the axis of symmetry, and we have that number right here in the table. We have x equals the 2.5. That's this line right here. So let's see where it's increasing. It starts at the wall, which is the 2.5, and it's going to positive infinity. Now for the orange, it's starting all the way to the left and hitting the wall. All the way to the left is negative infinity. And then we've already determined a couple times now that the wall is 2.5. You just have to spell it right. Now in this problem, we're talking about translating. So how much is it moving from the origin? So it says we're moving 3 units up because it's a positive 3. Now what you need to recall is H is your left and right movement, and K is your up and down movement. So since K is your up and down movement, we know that K equals 3. Since it says nothing about horizontal left or right, then we can say H is really 0. There is no movement. So if we plug that in, which looks really weird because there is no movement, we don't need to write that. So then we have parentheses, x, and then squared plus 3. But that even looks weird. We don't need the grouping symbols. We don't need the parentheses if there's nothing but one term in there. So all you need to do is y equals x squared plus 3. So that's going to be the case when we're talking about the vertical. It's the number outside of the parentheses, or the number that's on the end. Now, the next slide, slide 12, is dealing with the h value. And our k is up and down. The reason why I know is because it says horizontally 6. Since it's a positive 6, h is positive 6. And since there's no mention of vertical, we can assume that k is 0. Now, if we plug that back in, remember, x minus comes from the form, and then we have a 6, a positive 6. So minus a positive is just a minus, and then plus 0. But that plus 0 is not needed, so our horizontal translation is a 6, and that goes inside the parenthesis. But remember, inside the parenthesis is already x minus.